Yeah, hi there. In this tutorial, we are going to cover ggplot 2. Basically, what we will do, we will take one plot and we will try to build it from the scratch and keep on adding layers to it. So, as you know, ggplot 2 is a visualization library in R, and it is based on the principle of grammar of graphics. What it actually does, it builds the plots based on the principle of adding layers on top of it. So I have covered the basics of ggplot2 in my previous two tutorials. So this is the third one in the series. So let me start by first loading the libraries. I'm loading two libraries. First is ggplot2 and the second one is the lubridate. So this package is basically used to deal with any date time kind of variables or columns. So okay, so I'm reading data from a file which is a CSV file. This basically file contains the scores of Sachin in World Cup. So in his career, whatever World Cup matches he played, so all these scores are captured in this file. So it's just a CSV file. So I'm reading it into a data frame DF. Now the data is read and we can display the first five records using the head function. So I'm just saying head and it will display this data here, as you can see in the bottom. Otherwise, what we can do, we can just click on this object and it will open in a new window. So we have a column against. So this is like the team name against the team Sachin made the score, and the date when that match was played, the runs he made, the number of balls he faced, number of fours and sixes he hit in that particular innings. So from this, what I'm doing is I'm converting first of all this date field which is there in this the second column into actually the date time format because it's coming as a string. So using this parse underscore date time of this lubridate package which we had imported earlier, we are converting it into date time format. And then what I'm doing is I'm just extracting year part from this date and adding this is string basically WC. So it's like I'm extracting the year and then appending that year into this string WC. So basically I'm just preparing a new string as World Cup dash and that particular year of that World Cup when the match was played. So and I'm storing this result back in a new variable called as World Cup year. So this is done. Now let's quickly have a look at the structure of the data frame. So this is what our data frame looks like. If you see, so we have date. The first column is against which country he played, and second is the date, represents the date when that particular match was played. Then the runs scored by him in that innings, balls faced by him in by Sachin in that innings, number of fours and number of sixes scored by him, and the year that we had. This is a column that we had derived based on the date column that was present, and this represents the World Cup, in which World Cup actually that particular match was played. Okay, so I'm just setting one option Saipan S999 so that basically it is used to set when you don't want the large numbers to be represented in a numerical format, that is in an exponential format. Okay, so I'm just setting it up. Now next is I'll build first the basic scatter plot. This is basically the scatter plot where I'm trying to find out the relationship between the number of balls played by Sachin in an innings, in a World Cup innings. Basically, this is all World Cup data. So in the World Cup innings and the number of runs he scored in that particular innings. Just trying to find out the relationship as he faced more number of balls, then how he was able to score in that particular innings. So I'm doing ggplot, so that's the name of the function. So within the function, first we have to specify the data, like which data frame the data is having. So I'm saying data equals to df, so that's the name of the data frame. Then we have to specify the aesthetics. So in aesthetics we specify which particular columns of the data frame should be mapped with uh, x-axis or y-axis or different aesthetics like color, size, etc. So to start with, I'm saying on the x-axis I want to see the balls, and on y-axis I want to see runs. So I'm just storing this particular base object into a variable g, which is basically a ggplot object. Now we'll start creating layers on top of this base object small g that we had created. So first what I'm trying to do is I'm adding points to it. So how to add the layer? So we just have to use the plus symbol to add a layer on top of the previously built object. So g plus geom underscore point. So it means I want to see points or circles in the graph and want to visualize it. So let me run this. So if I see in the output, we get like this. So if we see balls here and the number of runs scored, and these are all the data points, of his different innings. Next is since all these circles were as black, we could, which is the default color. If we want, we can change the color. Let's say if we want the color to be as a steel blue, we just have to specify the color as a steel blue within this geom underscore point function. So this time it's the same data, just the color of the data points has changed from black, default black to the steel blue color. Next is now since these data points belong to the different World Cups he played. Now what I want is these points should be colored based on the World Cup. For example, if he played the innings in certain World Cup, then those innings should be mapped with one specific color, and for a different World Cup, the data points should be of different color. So to achieve this, what we have to do, we have to specify aesthetic of color as World Cup year, and we have to specify it in geom underscore point. So what I'm trying to say is this is the base plot small g. I'm adding a layer on top of it by this plus symbol. The layer I'm trying to add is the point layer, so which I'm specifying as geom underscore point. Now within the geom underscore point, I'm specifying another aesthetic. The aesthetic I'm specifying is the color, and I'm saying color all the data points based on the World Cup year. So if I execute this, this is what we get. So if you see now this time all those circles are colored differently based on the year in which that particular score was made by Sachin. Next is we can adjust the x-axis and the y-axis using two functions xlim and ylim. So basically we are trying to limit the x-axis and the y-axis. Now let's say if our requirement is to find out uh, only those innings or to display only those innings when he played at least 50 balls and at most 100 balls. That is, I want to focus only on those innings when he faced between 50 to 100 balls, and I want to see how did he do in those particular innings. So basically what I'm trying to do is I'm just limiting my values. So on the x-axis we have number of balls he faced in that inning, so I'm just limiting it between 50 to 100. So what we have to do is rest, the first thing is same what we did earlier, that is g, which is the base graph, plus geom point. Aesthetic color is based on the World Cup year. Now now I'm adding to this another layer which is to limit the x-axis. So I'm limiting the x-axis, which is the number of balls he placed, between 50 to 100, and on the y-axis I want to limit between 20 to let's say 120. So I want to see all those innings, so where he faced at least 50 balls and at most 100 balls, and he scored at least 20 runs and at most 120 runs. So I'm putting limit on both the sides between balls and runs. If I execute this, this is what we will get. So on the x-axis, if you see now, instead of starting from 0, The because of the limit that we had specified is starting from 50 going to 100. Similarly, on the y-axis, we had specified limit from 20 to 120. It goes like that. Now, another thing to note is whenever we are specifying the limits, uh, so any data that does not fall under this limit, it actually gets dropped. So if you see drop actually from the chart. So if you see in the warning message, you will see that 26 rows were removed to create this particular plot because those rows did not fit, because the values of those rows did not fit within this limit that we had specified. Now there is another method actually to achieve the same output in which we don't have to drop any data points. So it's like you are zooming in on only particular area. So the full graph is there, but instead of displaying the full graph, we just want to zoom in on a particular area. Then we can achieve the same thing using this a function called as coordinate underscore Cartesian. So the so rest of the things are same, just the base plot small base object small g plus adding the points to it, which should be colored based on the World Cup year. And another layer that I'm adding is coordinate Cartesian, where I'm specifying the x limit between 50 and 100 and y limit between 20 and 120. Now if I execute this, I get the same output that I got earlier. So on the x-axis, number of balls between 50 to 100, and on y-axis runs between the limit that we had specified, and these are color based on the different World Cup year. Now, if you see, I didn't get any warning here, like we got in the earlier case when we were specifying the limit. So this is a nice method to actually zoom in any particular area between the limits that we want to without actually dropping those points from the graph. Next is let's say I want to add title and label. So the graphs that we had created so far, these graphs do not have any title, uh, even though they have labels on the x-axis and the y-axis, but title is missing. Okay, now I want to give title, and I want to make some changes in the labels that appear on the x-axis and the y-axis. So by default, these labels on x and y-axis will come based on the column names that we had selected at the time of specifying the plot. So how do we specify the title and other text is by using labs function. So what I'm doing is G1 is basically I'm using this base plot small g, base object small g, and adding to it this layer geom point where the data points are colored based on the World Cup year, and the size of the data points, that is how bigger the data point should be, it is based on the number of runs Sachin scored in that innings, and I'm storing it in another object called as G1. Let me just quickly create this G1 and print it. Yeah, so this is what our graph looks like. Balls he faced and runs scored. Now all these you see are different color based on the World Cup year. Another dimension that is added is the size. So if you see, the size of the circles is smaller or bigger based on the number of runs he scored. For the greater the run, the bigger is the size. Now, in this graph, we want to add text like title, subtitle, caption, etc. So we can do this by using the labs function. So G1 is the object that we had created. Now I'm adding another layer to it, which is using this function labs, specifying the title as Sachin's score in World Cup matches, subtitle uh, between the year he played, and on the x-axis is the balls played, y-axis is the runs scored, and caption I'm saying World Cup scores. I'm storing this entire thing in another object called as G2, and I'm just printing it out. So if you see, this will be a much better graph compared to what we had created earlier. So now we have title Sachin's score in World Cup matches, the subtitle, and on we have a caption this here World Cup score if you see, and then on the x-axis we have label as balls played. So this is not what was the column name. This is the different value or the custom value that we had specified using the labs function. On the y-axis, it is the runs code. The rest of the things are same based on what we were getting earlier. Now, another thing that we can do is we can select color from any specific palette. So there are palettes in which predefined colors are there. For example, one such palette is set one. So what I'm doing is I'm specifying this palette using scale color brewer function. So to our base object G2, I'm just adding another layer, scale color brewer, and I'm saying palette equals to set one. So whatever colors are defined in this default palette set one, those color will be used to color the data points. And I'm storing the object in G3 and printing it out. So if I just execute this and see the chart, it's taking some time. Yeah, so and we see the output where the color was used based on the palette set one. So if you see the colors of this time are different, these are brighter colors. Basically, this palette had has brighter colors in set one. So you see the brighter colors coming, and rest of the things are same what we had set earlier, based that is title, subtitle, caption, etc. Another thing that we can achieve is we can change the labels. So if you see in this particular chart. Uh, on the x-axis, the balls he played are at a distance of 0, 50, 100, and 150. Similarly, runs code is again at the interval of 50. Now this interval we can change, and we can also create a different labels for it. So let's see how we do this. We can do this using scale x continuous. So basically the x value and the x-axis and the y-axis in our case are both continuous. So I'm using scale x continuous because had it been a discrete, I would have used scale x discrete. So basically what I'm doing is I'm changing the scale on the x-axis and scale on the y-axis, and which function we have to select, it depends on the data. If it is continuous data, we select continuous. If it is discrete, we select discrete function. And if we are specifying some manual values, then we select scale x manual or scale y manual. Okay, so what I'm doing is I'm saying G3, this is our base object that we had created here. Now I'm adding scale x continuous and I'm specifying the breaks. So the breaks is start from 0, go up to 150, and at an interval of 25. So it will create tick marks at 0, 25, 50, 75, 100, and it will go up to 150. Similarly, on the y-axis, I'm saying start from 0, go to 160, and at an interval of 50. So it will create on the y-axis as 0, 50, 100, and so on. Now, what I'm doing additionally on the y-axis, I'm specifying the labels. So instead of 0 coming as numeric 0, it will be coming it as ZERO. Similarly, 50 as numeric 50, instead of numeric 50, it will come as FIFTY50, and 100 will be displayed as century, and 150 will be displayed as numeric 150. So this is the custom label that I'm trying to display on the y-axis. So let me just quickly create this object, execute this and store it in the object G4. And let me just display this G4. Yeah, this is that you see on the x-axis. Now it's between 0, 25, 50, 75 at a space of 25 balls, and on the y-axis you see our custom labels are coming as 0, 50, century, and so on. And the last thing I'm doing in this tutorial, I'm just adding a theme to it. So there are themes available like themes classic, themes BW, and many other themes which we can add to our object, and we can display the object based on the theme that we have selected. So let me select a classic theme. So if you see, this is much better looking what I was getting earlier. Yeah, so that's it for now. We'll cover more in the next tutorial. Thank you.